I have 10 a.m., so I'm going to go ahead and get started. Again, this is going to be about tropical cyclones and tropical weather training. My name is Tom Green. I've been a forecaster here at the National Weather Service office in Raleigh for almost 3 years at this point. But before I started forecasting here, I did previously live in Raleigh. While I have not necessarily had all of the hurricane experience that you guys have with Florence and other storms like that, I was in Raleigh for 1996, and I clearly remember Hurricane Fran and the impact that it ended up having on Raleigh. And I remember not having any impacts from Floyd in Raleigh itself, but I do remember how devastating it was for all the locations east of I-95. So even if I haven't been here for all of the recent events, I certainly do have a history with Raleigh and what ends up going on with tropical cyclones around here. So going ahead, the first thing that I wanted to discuss was what office covers different people who might be on this call. So many of you are likely in the Raleigh forecast area. There are 3 offices in North Carolina: Raleigh, Wilmington, and Morehead City. However, the state is actually covered by 4 other offices as well. The northeastern part of the state is covered by Wakefield, the northern part by Blacksburg, Virginia, a good portion of western North Carolina by the Greenville-Spartanburg office, and there are 2 counties, Cherokee and Clay counties, that are covered by the Knoxville Tri-Cities office. So here's a list of the 2022 Atlantic tropical cyclone names. So Danielle's finished up and Earl is finishing up as well. So that's the entire list. Certainly hope that we will not end up needing this entire list. I'll also go ahead and say that for most of the slides that you're going to end up seeing, I did not necessarily create them myself. I'll end up giving credit to the different people whose presentations I borrowed from at the very end on the last slide and everything. There are a couple that I ended up putting together, but I certainly want to acknowledge the work that others have done in deciding to put together this training, that I felt it was something that we should do locally, so I borrowed from several people's presentations. A broad outline is that we are going to go over the climatology of hurricanes. We're going to talk about some of the National Hurricane Center products and also local Weather Service Raleigh products. Talk about hazards and general preparedness. So the climatology. The hurricane season officially runs from June 1st to November 30th. There has been some unofficial discussion about officially starting the season May 15th, considering how active it has been in recent years during that May 15th to June 1st period, but officially the hurricane season runs from June 1st to November 30th. And again, you have some averages there. Average day of first named storm July 9th, first hurricane August 10th. And so you can end up seeing, again, that graphic is a little bit older. It shows a period of record from 1966 through 2009. So it doesn't have the last decade, but it does end up showing you that we average about 2 major hurricanes a year, 6 hurricanes, and 11 named systems in that 40-something year period. The peak of the season is around September 10th. Oh, wait, what is today's date? September 10th. That is slightly coincidental, not completely coincidental. This is typically around the peak of the season, at least when it comes to the number of storms that we end up having. And again, as I said, the official season is June to November, but that doesn't mean that we can't have a storm before that or after that. I am going to take a quick look at the questions here, but I do not plan on answering questions during this talk. I will end up answering questions at the end of the presentation. So I will take all of the questions then. Let's see. So taking a look at the National Hurricane Center. Let's just start with this product, since this is probably the product that the Hurricane Center is the most known for. The cone represents the probable path of the center of the storm. The cone does not show the impact. So when you end up seeing each of those dots, the M's, the S, the D, that is showing where the center of the storm is expected to be, but nothing about the cone does anything to show what the impacts are going to be. The cone is the same for every storm in the sense of the size of the cone. The cone doesn't change depending on the storm. Some storms are smaller in size, some storms are larger in size, but the cone does not have a different size for a different storm. It is based on the average error that the Hurricane Center has with their forecasts. And that bottom bullet says the center of the storm passes within the cone roughly 2/3 of the time. So that forecast from Monday, September 10th, 2018 was showing that at 2 p.m. Friday, the center of Florence was expected to be very close to Raleigh. However, that doesn't mean that the storm actually was there. So that's why we always end up saying that people shouldn't focus on it, the exact location of the storm in the cone itself. You should really focus on the cone because the average error from the Hurricane Center is built into this particular product. And again, a slightly different look at this from another person's presentation. It does highlight the areas that are under watches and warnings. So you can see for this particular case, Hurricane Joaquin back in 2015, you can see the blue and red shading that was going on over the Bahamas. Certainly nothing up in Canada at that point. It would be way too far out for that. And again, to form the cone, a set of imaginary circles are placed. And again, the size of each circle encloses 67% of the previous 5 years official forecast error. So in that sense, the size of the cone does change each year as to how wide the cone is. But again, that cone is a static size during a particular year. And the scheduled issuance of this is at 5 a.m. and 5 and 11 a.m. and p.m. So what is the official track error trend of the Hurricane Center? So you can see each of those different colored lines showing what the average track error has been in the Atlantic Basin as opposed to the Pacific Basin over each of these different decades. So you can see that if you were looking at 72 hours, 1960 to 69, the average error was approximately 400 miles back in that decade. If you come down to 2010 to 20, in that decade, you can see that the average error was only about 100 miles for that decade. And if you were to go back in time, that's about as good as an 18-hour forecast was back in the 60s and the 70s and even into the 80s. So you can see that it's pretty impressive that at this point, our forecast error at 72 hours is about what it was in the 80s at only 18 hours. And so definitely we're very happy to see that this line continues to trend downward. So at this point, they are doing experimental forecasts that are internal to the National Hurricane Center, looking at a 6-day and a 7-day forecast. However, they do not have enough confidence to issue those forecasts to the public. The official forecast only goes out 5 days, and that track error is approximately 200 miles. So what is the forecast cone over the different time periods in the Atlantic Basin this year? So again, the average error is approximately 26 miles for a 12-hour forecast. The average error in a forecast is approximately 200 miles at the 120-hour forecast. And so those numbers change very slightly each year, just by a mile or two for the most part. But that determines what the size of the cone is as we end up going through the 2022 season. And again, a graphical way to end up representing this, just taking a look, you can end up seeing the cone in 2005 in purple, then blue and green and red, showing you how for a storm in the same location, how that cone would be drawn smaller in each of those given years as the forecast accuracy has increased. So what was the difference if you were to look at the cones with Hurricane Floyd in '99 versus Hurricane Dorian in 2019? Again, you can see just how much smaller that track forecast is in the previous 20 years. Now let's talk about intensity. We haven't had as great of improvements to intensity over the years, although you can see that it is still a noticeable drop between the 2000s and the 2010s at most time periods past 24 hours for the most part. And again, you can see those internal forecasts on days 6 and 7 that are not going out to the public, but you can see that in the 70s, 80s, 90s, and the 2000s, the forecast intensity was very similar over time. There wasn't a lot of improvement with that. There are a lot of factors that end up going into the models and predicting the intensity. A lot of times when there's rapid intensification of a storm, that is something that the models end up having a hard time capturing. And so that can end up accounting for a lot of that intensity error, because there are times that a hurricane will just take off and increase in intensity by 50 miles over a 24-hour period, 50 miles per hour, that is. So when we end up having that, that contributes a lot to those larger intensity errors that end up occurring. So how do we classify all of these storms? A tropical depression is when we have winds that are less than 39 miles an hour, and you must have a closed surface circulation. That's important, and I'll come back and touch on that a little bit later on. Tropical storm is 39 to 73 miles per hour, and a hurricane is anything 74 miles an hour or greater. And then also we classify a major hurricane to be anything that is 111 miles an hour or greater. And so that would be a category 3, 4, or 5 storm. And here is the Saffir-Simpson hurricane scale. And I do want to emphasize, as it ends up saying on this graphic, it is the Saffir-Simpson hurricane wind scale. This only accounts by wind speed. This does not include what the lowest central pressure of the storm is. This does not include what the greatest storm surge is. This does not include what the greatest rainfall is. The Saffir-Simpson hurricane scale relies solely on what the maximum wind speeds are. And there have been discussions about creating other scales that could end up being used. But at this point, when you hear about a category 3 storm, that doesn't tell you anything about the storm surge, that doesn't tell you anything about the rain, that doesn't tell you anything about the pressure. All it tells you is that the maximum wind is 111 to 129 miles per hour. Again, a wind scale. So this was a neat graphic that I hadn't seen before, that I saw as I was pulling together some of the different presentations. This is looking at the average frequency that different coastal counties end up having a hurricane, end up affecting their county. Now, I'm pretty sure that this is the actual track of the storm. I don't believe that this is just looking at the impacts. I believe that this is that how this graphic was created was that the track of the storm specifically moved over a given county. So you can end up seeing certainly Cape Hatteras sticks out enough that it has a return period of only 5 years. So in that sense, Dare County is the most frequently affected county. Certainly the Florida Peninsula sticks out. Certainly the area south of New Orleans and Louisiana sticks out. You can see that this one county in Texas manages to be shielded a bit from having the track. And then certainly as you end up going up farther to the northeast, with the exception of Cape Cod, you can see that it's much less frequently that we end up having a hurricane end up going through. Now, of course, just because this number ends up saying 50 doesn't mean that if they get a hurricane, they're safe for 50 years. It's on average, it takes about 50 years. And a similar graphic looking at the major hurricanes, you can see that those color scales are pretty similar, not exactly, but still the Outer Banks end up getting hit more frequently. The Florida Peninsula ends up getting hit more frequently. Louisiana ends up getting hit more frequently. So again, if a county ends up getting hit, you know, if Hatteras is hit, it doesn't mean that they're going to have another 16 years until the next one ends up coming through. This is just an average return period for how long it will end up taking. So we calculate averages every 10 years, and seasonal averages cover a 30-year period. This is the case whether we're talking about the average high and low temperature. This is also when we end up talking about the average number of named storms, hurricanes, and major hurricanes. So effective in the 2021 Atlantic hurricane season, the average season went up by 2 named storms and 1 hurricane. The major hurricane stayed about the same. And as it says, numbers for an average season reflect the climate record for tropical storms and hurricanes and use the most recent 3 decades as the period of reference. So obviously that 1991 to 2010 period was unchanged. What that ends up telling us specifically is that the 2011 to 2010 10-year period was busier than the 1981 to 1990 period, because 20 of those 30 years remained the same in both of those records. So the 2010s had more hurricane activity than the 1980s decade did. All right, now let's start talking about the actual products that the Hurricane Center ends up issuing. So this is a picture of the National Hurricane Center in Miami and Florida. They forecast the track and the intensity of the storms, and they are responsible for all of the tropical cyclones that end up affecting North America. They cover the Atlantic Basin and they cover the Eastern Pacific Basin. As you can see, the building has very thick walls reinforced with a lot of concrete, so they are able to withstand Category 5 hurricanes. I don't believe our building is designed to withstand Category 5 hurricanes. Our focus when we end up doing these forecasts is we are working more specifically on the impacts and the threats for our local area. But we are going to take the track and intensity that the Hurricane Center ends up forecasting, and that is the exact forecast that we will end up relaying onto you. But we are doing this collaboratively with the Hurricane Center to decide where the watches and the warnings are issued. So again, a lot of these products you can find on hurricanes.gov, or you can look at weather.gov/Raleigh/tropical. The tropical weather outlook is a product that is issued 4 times a day. There are 2 different tropical weather outlooks. There's a 2-day outlook and a 5-day outlook. This one specifically is showing the 5-day outlook from several years ago. If the tropical storm and hurricane forecasts come out at 5 and 11 a.m. and p.m., this product comes out at 2 and 8 a.m. and p.m. So every 3 hours, the Hurricane Center is putting out some type of a forecast. This is their broader outlook, and then on the 5s and 11s are when they're issuing the forecast to the particular systems themselves. Now, a hurricane watch is when sustained winds are possible within a specified area within a 48-hour period. Watches can have different time spans over the different types of watches that we end up issuing in the National Weather Service. For example, hurricane watch is looking at possible conditions within the next 48 hours. A flash flood watch, such as we have today out in the Triad, might be for something that's in a ballpark of 24 to 48 hours. When we issue severe thunderstorm watches or tornado watches, those might be for a period of 6 to 12 hours. So I'd want to emphasize that I'm not trying to confuse you by throwing all those numbers at you. I just want to let you know that the time scale that watches and warnings are in effect for depend on the product. And a hurricane watch and a tropical storm watch are specifically looking at possible conditions within the next 48 hours. Meanwhile, if we are in the warning phase for hurricanes or tropical storms, that ends up meaning that we're looking at something in the next 36 hours. Again, a winter storm might be 24 hours. A severe thunderstorm or tornado warning might be within an hour. But a hurricane warning or a tropical storm warning is saying that we have high confidence that those conditions will be met within the next 36 hours. Potential tropical cyclones. This is the entire reason that made me want to put this presentation together in the first place, because there was potential tropical cyclone 1 that we had at the beginning of the season. And I wondered how many people even knew what that meant. What does potential tropical cyclone 1 mean? Why wasn't it, tropical storm A watch and everything? Well, as I said before, we don't have a tropical depression until we have a closed circulation, an actual low that is formed. So there are times that we think that we could end up having a tropical storm end up forming or a hurricane forming, but we don't have a closed circulation yet. And in those cases, as this says, this is issued before a tropical depression or a tropical storm forms. This is when we have what we would call an open circulation. as opposed to a closed circulation. You might have some stronger winds, but there isn't a closed low center. And this allows us, the agency, to issue a watch with a full 48 hours of lead time or a warning with a full 36 hours of lead time prior to possible tropical storm, hurricane, or storm surge conditions. And all of the standard advisory text and graphical products are issued at particular times, but this just ends up occurring before the closed circulation has occurred. The key message graphics are always produced by the Hurricane Center themselves. That is not something that we locally end up creating. The key message graphic combines the key message from the Hurricane Center discussion and pertinent advisory graphics, so it almost always ends up containing the cone in the upper right-hand corner, and the lower right-hand corner in this one, they decided to focus that particular graphic on the potential rainfall from the system. This is available through the National Hurricane Center social media outlets. It's available on their website, and it is something that we will occasionally end up sharing on our social media platforms as well, specifically Facebook and Twitter. An earliest reasonable arrival time graphic. This is in contrast to the most likely arrival time graphic. So this is showing a reasonable worst case scenario. This is a window that preparations should be made by. So for example, if you were by the triad for this particular forecast, it's saying, well, let me end up, this was a graphic created by Morehead City. So let me end up using an example for Morehead City. They were saying on this graphic that all preparations for Florence should be completed by Wednesday evening, because at approximately 8 p.m., and as this says, while times are given, especially farther out, focus on the more general terms. So it could be 10 p.m., it could be 6 p.m. But saying in this window, this is the earliest reasonable time that Hurricane Florence was expected to get to the North Carolina coast. So if you needed to have all of your preparations complete, we always end up saying that kind of by the time that that these tropical storm force winds are expected to arrive, that all of the preparations should be complete. And then this color coding is showing, it's a little small to read here, but it says 5-day chance of reaching sustained 34 knot winds. So even at this point, there was a red chance, so about a 70% chance, or even a little bit higher, that those winds would make it to Raleigh. But this was, essentially guaranteeing that at least a tropical storm wind would make it in the next 5 days to the Morehead City coastline. So this is kind of the earliest time of arrival, and you really should have all of your preparations done by then, as opposed to a most likely arrival time. And I'm sorry that I'm using a different storm here. I didn't have a slide for Florence, but this is when the most likely time is, not the earliest time. So again, for this particular slide, they were kind of saying, again, this was issued by the Morehead City office. So kind of saying that for that area, kind of approaching Cape Hatteras, said it was going to be Monday 8 a.m. or just generally sometime Monday morning. So again, we have the earliest reasonable arrival time and then the most likely arrival time for the tropical storm force winds specifically. Okay, moving on to some of the hazards. It's not just the wind. Again, as I said earlier, the Saffir Simpson wind scale is only discussing the wind. Certainly, there can be flooding from rainfall, storm surge, rip currents, wind, tornadoes. I won't go heavily into details on all of these, but water is the biggest killer when it comes to tropical cyclones. Again, this graphic was created by Rappaport in 2014 and only goes through 2012, so it doesn't include anything in the last 10 years. But you can see that water accounts for about 90% of the direct deaths. Even if hurricanes and the Saffir-Simpson scale are talking about a category 1 through 5, only 8% of the fatalities over that 50-year period were wind related. Half of them were related to storm surge along the coastline. And then you can see about a quarter of the cases from rain, some sort of flooding. Then we can actually have high surf, something might be offshore on a ship, wind, tornado, and I don't know specifically what is included in the other category, but certainly water is going to end up being the biggest threat when it comes to a loss of life. with tropical cyclones. So here's a forecast for Hurricane Florence, the 5-day rainfall forecast on the left, and then the observed rainfall on the right. You can end up seeing those, you know, the yellows were 15 inches of rain. These isolated purples ended up being 25, 30, 35 inches of rainfall forecast and occurring in some locations. So excellent forecast saying that there were going to be places that were going to have 2 feet of water. Just to give you a ballpark, Raleigh averages about 40 inches of rainfall a year. So this was saying that you would have more than half of the rainfall for the year, at least in Raleigh. I realize I'm mixing Raleigh and Wilmington. I don't know how different it is for Wilmington. But even looking at this was saying 7 to 10 inches of rainfall, or kind of right on that line here, about 7 inches. Again, you're looking at 2 months of rainfall occurring in 5 days. But out of the 17 flood-related fatalities, 16 of those people were in vehicles. So the necessary precautions were not being taken to watch out for the power of the water. The second deadliest 2019 Atlantic Basin storm was Lorenzo, with 19 direct fatalities, all that were water related. You can see that that remained thousands of miles away from North America. And there were 8 rip current deaths in the US just for North Carolina alone. And so dangerous rip currents can occur well ahead of approaching storms. So even if a storm is nowhere near us, we always end up emphasizing to people that they should end up taking a look at the rip current forecast. Those are done by all of the local offices, I should say, the coastal offices, and we will occasionally end up letting people know about those forecasts on Facebook or Twitter. But certainly they're prominent on the Morehead City webpage, the Wilmington, and any of the other coastal offices as well. So general beach safety, I will not read this entire slide out to you, but rip currents escape the grip of the rip. You want to make sure that what you end up doing is you don't want to try and fight a rip current and to go against it as it's trying to push you out farther into the water. You always want to make sure that you swim parallel to the shoreline, head in the direction of the shoreline, because a rip current is normally a very narrow current of water. So in this particular case, if you were to swim to the left or the right, you would end up getting out of that current, and then you would be able to make your way safely to shore. And again, many beaches, not every beach, but many beaches will have flags to end up warning you of what that particular rip current threat is. Certainly tornadoes are a threat when it ends up coming to hurricanes. These typically end up occurring on the right side of a storm. This is the side where winds are typically blowing onshore because we have cyclonic or counterclockwise flow. So that's why the winds are blowing onshore there. So we're getting a lot of warm and moist air that's making its way inland. As the hurricane makes landfall, friction slows winds close to the surface, while the winds higher up aloft are still spinning rapidly. And this is a favorable wind profile for tornadoes to form. Whether or not there's a hurricane around, that is also a favorable environment just on a regular basis. If we have a cold front coming through, if we have stronger winds higher up in the atmosphere than at the surface, that helps to organize storms. And tornadoes spawned from tropical systems rarely have lightning, and are even more rarely associated with hail. They are also much quicker normally in duration. Some of them only end up lasting a minute or two. You don't have nearly as many tornadoes that track for 10 or 20 or 60 minutes. So this can also make it difficult for detection of tornadoes, depending on how quickly the storm develops and what mode we have the radar in. There's a possibility that a circulation could develop and disappear before it even has a chance to appear on the radar. So again, taking a look at that right front quadrant, if that storm is moving from southeast to the northwest. And the friction over land creates low-level wind conditions that are favorable for the development of tornadoes as well. Local time zones. Anytime we end up putting a product on the weather radio, we try to always end up changing whatever the time zone is that the Hurricane Center ends up issuing the product in, because the Hurricane Center may use Central Time or Eastern Time or Atlantic Time or Greenwich Time or Cape Verde Time. All of those time zones have their differences. Notice it's 11 a.m. Eastern Daylight Time, while Atlantic is Atlantic Standard Time. That's why they're both 11 a.m. We do our best to convert all of the products when we're playing them on the NOAA weather radio. If something was listed as 10 a.m. Central Time, if something was in the Western Gulf of Mexico, we try to convert that to 11 a.m. just to keep everything easier. So these are the times that the public advisory, the discussion, the time of arrival graphics are all applicable. We have our own local tropical page. It's weather.gov/RAH/tropical. It's your one-stop shop for all tropical related local forecast information. There's an active storms tab that becomes active when the Hurricane Center initiates tropical cyclone advisories. And just kind of reading off the top here, again, this is not the Raleigh one. This screenshot was taken from the Corpus Christi office. So there's an Outlook tab, active storms, threats and impacts, local products, satellite, radar, social media preparedness, and other links. So here it's showing a local briefing. This was showing the 2-day outlook and the 5-day outlook for this particular case, since they were on the Outlook tab here, but the Raleigh page would look very similar to this Corpus Christi one. Again, this would end up showing the active storm. So in this case, again, from the Corpus Christi office. So this is looking in on the Hurricane Harvey forecast cone at that point and showing where the current wind extent was in the shading, and then you could see where the hurricane warnings were and the tropical storm warnings were. And then going a little bit more specifically, again, this is again a screenshot off of, this is off of the Corpus Christi page, again, taking a look at the threats and impacts. They contain the HTI information, which I'll go over in a second, but there are 4 major threats that you can see perhaps the radio buttons for here, and that includes wind, storm surge, flooding rain, and tornadoes. And this helps to communicate the degree of preparation that is needed with a safety margin built in. And these threats are normally based on products from the national centers. Again, so the wind threat is going to be from the wind field that the National Hurricane Center is predicting. When it comes to storm surge, that is also a prediction for the National Hurricane Center that they do. We do not specifically end up having to worry about storm surge inland here in Raleigh. That being said, we're making sure that we mention storm surge in this presentation because we know how many people may have interests down along the coast. The flooding rain threat is issued by the Weather Prediction Center, and they issue excessive rainfall outlooks across the entire continental United States. And then the tornado threat is issued by the Storm Prediction Center out in Norman, Oklahoma. So all of those threats are created at a national level, and then the local tropical webpage is showing you a zoomed in version of those threats locally. Didn't realize I had those arrows there. All right. So again, going on the local products. So the local products tab is shown when there is an active storm. And again, this is another graphic from Corpus Christi. You can view the entire hurricane local statement here, and there are several other products. You can see all these listed here, and then there is the pull down here. So this was showing the hurricane local statement, but there are also many other types of statements that would be available from that pull down menu. Satellite and radar data is always available. There's also the preparedness tab that ends up providing quick access to local evacuation maps and other information like that. We have not had anything in Raleigh since I ended up putting this presentation together. We haven't had any local systems, and knock on wood, hopefully we won't for a while. That being said, I certainly hope to update this presentation down the road as we end up having some more local information. Though I do have some local slides coming up. If you are taking a look at things from the local weather forecast office itself, we always end up issuing a hazardous weather outlook that is always issued every morning, sometime between 3 a.m. and 7 a.m. And this is designed to alert our customers to expected hazardous weather and its potential out to the next 7 days. So I did copy and paste this in. This is the actual outlook that was issued at 5 a.m. on Tuesday, September 11th, 2018, talking about Hurricane Florence approaching. And as that second bullet on the left says, this will not reference any tropical cyclone activity beyond the time period addressed by National Hurricane Center products, which is currently a 5-day forecast. So again, if it looks like something might approach us on days 6 and 7, we are not specifically going to be referencing those. So this was the hazardous weather outlook that our office issued that encouraged people to prepare now for Hurricane Florence and said that spotter activation would likely be needed. A tropical cyclone local watch and warning statement is a good source of meteorological threat and impact information on a small scale. This is looking on a county by county basis. It is not a good source of information for the media and others who require a big picture. We do have a separate statement for that, which I'll get to in a minute. So an example of a local watch and warning statement. For example, this was the 11 p.m. local watch and warning statement, and this is specifically for Cumberland County in this case. So this is talking about how Fayetteville and Fort Bragg were impacted, what the peak wind forecast was for that particular area, that the potential, there was the buffer that maybe the winds could reach up to 58 to 73 miles an hour, and that the potential impacts were unfolding at that time. So again, this is getting specific. This is looking at a county by county basis, as opposed to the hurricane local statement. This is a concise summary of everything going on for an office. This is a good source of information for the media and others who require a big picture. This is not the product that you would want to look at if you're trying to look at things on a smaller scale. This is not the product that you want to end up using for official watch and warning information. And again, here's an example of the hurricane local statement. And again, not specifically for Cumberland County. This is covering our forecast area in general. Again, a Hurricane Florence local statement from Raleigh issued at 11:15 that night, covering central North Carolina. So there weren't any changes to the watches and warnings. There was a hurricane warning in effect for Sampson and Wayne counties, and a tropical storm warning for several other counties. And so again, the areas affected, the headline primary information, the new information, we were starting to include here. The storm information was saying that the storm was about 160 miles southeast of Raleigh, or 140 miles east southeast of Fayetteville, with a latitude and longitude, the current storm intensity. A situation overview, continue down here, and farther down, I don't have a screenshot of it, showing the potential impacts, precautionary and preparedness actions, and when the next update would end up going on. So again, this is not specific to any one of our individual counties. You would want to look at the local statement for that. Or, sorry, I said it wrong. You would want the local watch warning statement for an individual county. The hurricane local statement is covering our forecast area in general. So all of the areas in green can be included in a hurricane local statement. And this is something that has expanded over time. I know that there were a couple of areas that were added to this just in the last year, going further and further inland. So a hurricane and typhoon, well, no typhoon local statement here. That's a hurricane and a typhoon and a cyclone, just different basins. The Atlantic, Pacific, Indian Basin have different names. So all of the weather forecast offices in green, and that shows you again broadly where all of the different offices cover. The hurricane local statements are issued by all tropical weather forecast offices that are the area shaded in green. Extreme wind warnings are issued by Atlantic weather forecast offices in Hawaii only. An extreme wind warning is only when a major hurricane is expected. And again, that is a category 3, winds of at least 111 miles an hour. Then a post-tropical cyclone report is also issued by all tropical WFOs talking about the highest wind speeds, the highest rainfall totals, etc. Wireless emergency alerts. You've likely received these, maybe you have, maybe you haven't, for flash flood warnings in the past. Perhaps you have received them for tornado warnings. Our highest end severe thunderstorm warnings now can end up prompting these. What I want to focus on for this is that a WEA, a wireless emergency alert, is an alerting network in the US designed to send alerts out to smartphones. When it comes to a hurricane, it would probably end up being for the tornado warning, the hurricane warning, or perhaps a flash flood warning. These messages can be received in Spanish for devices with Spanish set as the primary language. They can go up to 360 characters. If you have a phone with 3G service or less, you will still receive a message. However, it will only be a 90 character message. At any time, whether or not there's a hurricane going on, you can always end up looking at an hourly forecast. If you go to weather.gov/Raleigh and do the point and click forecast and pick whatever point you're interested in. It is cropped out on this particular image, but you can end up choosing what variables you would like to see. So this particular plot is only showing the temperature, the surface winds and wind gusts, and what the sky cover is. It shows you for a 48-hour period. So this is from what, about 9 a.m. or let's say 9 or 10 a.m. to 9 a.m. Well, sorry, it says 10 a.m. right here. So 10 a.m. Tuesday to 10 a.m. Thursday. But this is a clickable box where you can end up choosing any hour. You can go as far out as you want in the forecast. And this is the official forecast that we have issued. We issue a gridded forecast. Our grids are approximately 2.5 kilometers, so about 1 mile to 1.5 miles in size. And we are predicting the temperature for every grid box in our forecast area. We're forecasting a wind speed and direction and gust for every box in our area. We are forecasting the sky cover for every grid in our forecast area. We are not, specifically looking at each of the thousands of boxes for the temperature. But we do have a forecast specifically for each area. And so you can turn on things like the dew point, the chance of precipitation, the amount of precipitation. So you can see these trends in hourly increments out to 7 days. And then you can also end up doing a mouse over. So at this particular point, when this image was taken, or this was a forecast issued showing this time period. But at Wednesday, November 20th at 3 a.m., the particular forecast was 41 degrees, surface wind west at 7 miles an hour, and a 51% sky cover. So up above this chart is where you would end up having checkboxes that you could check the individual variables that you are interested in looking at for the forecast. And finally, I wanted to spend a couple of slides talking about preparedness. So this is what you should do before the storm, not like in the week before the storm. Maybe that first one would be the case. But a lot of these are things that you could do now before anything is going on. You would want to develop your evacuation plan, have several routes, plan for your pets depending on what's going on. You would want to have your disaster supplies ahead of time. You would want to have non-perishable food, water, medicine, extra cash on hand, etc. Get an insurance checkup. Again, this may not be as much of a concern if you live in the triad or the triangle, but if you're closer to the coast, this could end up being an issue. Covering your windows, moving a vehicle to a safe location. You may help your neighbors evacuate. You may want to check in with them after the storm passes to make sure that everybody did all right. Have a written plan, have a contact list, have at least one contact outside of the area that could be impacted by the tropical storm or hurricane, and share your plan so that others know what you are planning on doing. Oh, I had clicks on all these, okay. Again, another slide talking about some of this stuff. You would want to have non-perishable food. A good rule of thumb is to have 1 gallon of water per person per day, whether that's for drinking, going to the bathroom, cleaning up, washing your hands, etc. Supplies for small children or pets, extra clothing, personal items. You'd want to have flashlights and batteries. You would want to have some sort of a NOAA weather radio or an AM/FM radio that is battery powered as opposed to something you would plug in. Make sure that you have important papers and have them documented. It would be good to have cash on hand because if there's a widespread power outage, then the ATMs probably won't be working. So you'd want to have that cash on hand. And I forgot these are all click through as well. So again, if your area ends up being in a hurricane watch, you would want to be monitoring NOAA weather radio, local media, your local website. This is going to be when you want to make sure that you have that disaster supply kit ready. You might just have it sitting in the basement. Well, you might want to get it out in an area that's a little bit easier to get to. Now is the time to get gas for your automobile. You don't want to be one of those cars stranded on the side of the road. Certainly, if you're under a hurricane watch, if you have something that's outside that you can bring inside, this is going to be your time that you want to do it. If something has to stay outside, you should end up doing what you can to tie it down. Board up any windows. You might want to turn your refrigerator and your freezer to the coldest settings so that they are cold in case the power ends up going out. And you would want to open the doors as little as possible to try and keep whatever is inside cold if the power does end up going out. Again, make sure that all of your prescriptions are ready to go and with your emergency preparedness kit. And decide where you want to go if you do evacuate, because depending on the route of the storm, you may decide that you want to evacuate to a different area. And certainly hotels are going to fill up quickly along the major interstates, so you may decide that you want to go a little bit more off the beaten path depending on where you're coming from. All right, if that hurricane warning is in effect, generally that means you're less than 36 hours before an impact. Continue to monitor your weather radio, our website, your local media. Be alert for and heed any evacuations that are issued by local emergency management. You'll want to make sure that you turn off your main water and gas to your house. Make sure that someone outside of the hurricane warning area knows your plans to make sure that they know where you're going to be. Again, if you live in a storm surge zone, not likely in the triad or the triangle, but if you're closer to the coast, again, make those get those indoor items as high as you can. You're going to want to bring emergency supplies with you. And you may decide that your home is your best shelter. Make sure that you stay as far away from your exterior walls and windows. Keep as many flashlights and batteries as possible near you. And when the storm nears, follow those same safety rules that you would for a tornado. You want to be on the lowest floor of your house. You want to be away, again, from all of those exterior walls and windows. The interior most room of your house is going to be the safest place. That likely will end up being a bathroom or a closet. So you may end up wanting to be there for several hours for your safety. After the storm ends up moving through, you're going to want to continue to monitor all available media sources to find out if there's anything that your local emergency management, local officials want to tell you about. Do not return home until you're advised by the authorities. Be prepared that you may come across injured people who may need your help. Stay away from any downed power lines. Assume that they are still live. Hopefully they are not, but do what you can to report those to officials to make sure that the power company can turn them off. Be alert for any wild animals who have also been forced from their homes. I hope the person who took that picture, I won't pretend to know the difference between an alligator and a crocodile, but I hope the person had a very good lens on their camera who was taking this picture. And you're also going to want to make sure that any food that you have that's left over in your house was not spoiled before you go ahead and consume that. Again, more things after the storm. You're going to want to take photos of the storm damage before you alter it for insurance purposes. If your home is damaged, you may want to open your doors and windows to try and ventilate and dry things out. Minimize the telephone use in driving. You want to keep the roads clear for any personnel that are out trying to go around and clear those power lines to let the police get and ambulances get to where they need to go. Stay off the phone lines to make sure that all the calls that need to go through can. And be alert for any gas leaks, electrical system damage, and water line issues. If you do have some ice cubes, you may want to melt them. since you know that those ice cubes were generated before the storm, and you know that there aren't any issues with any dirty water having gotten into your house at that point. So that generally ends up wrapping up my presentation. I want to give a thank you to the contributions for Chris Strong from the Sterling, Virginia office, which is near Washington, D.C., Eric Heeden at the Morehead City, North Carolina office, Jesse Smith from the Melbourne, Florida office, and the Southern Region headquarters, which is based in Fort Worth, Texas. Most of these slides that I ended up getting were put together by them in some form or another, and I did make some local modifications to them, but the bulk of this information was put together by them. So I certainly want to make sure that I end up giving them credit for the majority of these slides that I ended up putting together. So thank you to them for their help in the information that they provided.